Hello everyone, this is Module 6 and this is the first of 4 video presentations that I want you to go through for this module. This is just really an introductory part where we're going to talk a little bit about recapping kind of what we've done in the past and then get prepared for multiple regression analysis. So last week we picked 2 variables from the Boston housing set. The first one was average number of rooms, or RM, and then the other one was median value. We tried to show how the average number of rooms, or the RM variable, can be used to predict median value. So we ran a linear regression model in order to determine what the slope and intercept would be to complete out our equation using the variables RM and medv. So we built a model where medv is equal to the intercept, which our function in R gave us, plus the RM variable times the slope which also came from our function in R. And we were able to predict values for medv based on the average number of rooms in any of the neighborhoods in that file. We were also able to show the error, how inaccurate our model could be. If you look at Chapter 5 of the textbook, which would be the next logical chapter for us to look at, it starts talking about errors and how we can use errors to sort of assess the value of a predictive model. We're not going to go there just yet, because I want to go through one more example of a process or a function in R where we will actually generate errors. And this time, we're going to look at errors both in the training set and in the validation set. Actually, I'm going to show you how to do it in the training set. You're going to do it in the validation set. But once we have a little bit more experience with calculating sort of predictions and then determining what the error is likely to be with those predictions, then we'll go back and take a look at some of the ways that we can use error to assess the model. But instead of doing that this week, we're going to actually look at talk about multiple linear regression. So what's that? What's multiple linear regression? Well, what it is it's when we use regression to predict likely outcomes, just like we did before. But instead of using just one variable, we're going to use multiple variables. And why are we going to do that? Because if we can identify multiple variables that are in fact already correlated with the variable that we're trying to predict, then we're likely to be able to have much more precise measures, much more precise predictions, because we can really zero in on using a combination of correlated variables that will help us determine what the predictive variable would be. So what we're going to be doing actually is, instead of using just, like for example, in our example, instead of using RM to predict median value, what if we used RM and tax together? And between the two of them, they were able to come up with a much, much better prediction. And the way that they do that is that when we put it into our LM model, we're still going to get just one intercept, just like we did before. But this time we're going to get 2 slopes because we have 2 independent variables. And so those 2 slopes, each one will be specific to the variables that we selected, and when we build our equation, we will use those slopes to actually finish out our equation. So our equation, when we had 2 variables, would look something like this. Median value would be equal to the intercept plus RM times the first slope plus tax times the second slope. Now, from here on out, we're not going to call those slopes anymore. We're going to call them coefficients, because that's the actual title that statisticians use when dealing with multiple linear regression. So just note that we'll call them coefficients from here on out. But anyway, if we have selected wisely, we're going to get a much more accurate model. So in the 2 next videos that I want you to watch, they're actually from an external source. And there's a guy on YouTube named Brandon Foltz, and he's a statistician and an educator. And he creates videos that are for people to use. And he wants you to like them, and he wants you to, give him the thumbs up. And sometimes he's asking for financial support. Don't worry about any of that. If you like him, you can go ahead and give a thumbs up. If you want to subscribe, go ahead and subscribe. We'll use a couple of his videos throughout the remainder of the class, but there are 2 videos he's got on multiple linear regression that do a really great job of explaining it. So I'd like you to do those first, and then when you finish with those 2, there's going to be a 4th video. Come back to the Canvas shell, the module in the Canvas shell, and you'll find a 4th video, and that 4th video will actually walk you through the example of the assignment that I want you to do today. All right, a couple things I want to define out. First, 2 things really only. First, the first one is from statistics, p-value. P-value, in its simplest term, is the chance that the results you got were purely by chance. What's the likelihood that what you just came up with in your equations or functions was just purely by chance. And so you want to get a low p-value because you want your results to mean something. So if your p-value is less than or equal to 0.05, then that's often a kind of a cutoff point that many statisticians use that says that there's a pretty small chance that the results I got were just purely by chance, which on the other side is interpreted as my results are significant. So the reason why I bring up p-value is because Brandon Fultz uses it in his videos, and I want to make sure that everybody's just familiar with the concept of what a p-value is. He also talks about error, and error, of course, is the difference between your predicted value and your actual value. We've already seen that in the single variable linear regression, but he brings it up a lot more, and we'll talk about it a lot more. If you're really kind of being fully concerned with error, then when you are looking at, for example, the average number of rooms and the median value, those two variables, when we compare them in a single linear regression, we would have our outcome is y. It would be equal to the intercept plus x, our input variable, times slope, and then we would also add an error, and that would give us the most accurate measure because we're now accounting for the amount of difference between the error measurement and the actual, or the predicted measurement and the actual measurement. Anyway, he'll talk a bit more about error in his videos, and we'll talk a bit more about error in the fourth video. Okay, but those two things should get you through the Brandon Fultz videos. Like I said, go ahead and watch those. They're about 20 minutes each, but they're good information. The second one is a little slow, but you kind of get the idea, and he still goes on and on. But anyway, it's still useful. And then when you come back, watch the fourth video. The fourth video is going to walk you through. I want to do something a little different this time. I'm not going to go do a PowerPoint on this one, or if I do a PowerPoint, I'll just do a very introductory one. I'm going to walk you instead step by step through an R script that I wrote. I will give you access to the R script, of course, but I'm going to walk you through step by step each of the commands that's in the R script, and it will get you only so far. And then you're going to have to take over and do the rest. Okay, I'll see you back here for the fourth video.